In this video, I'm going to talk about compound inequalities. Well, a compound inequality, remember, is when you have two simple inequalities and then they're combined into one statement, and we're going to combine them using words and or. So let's look at a couple of examples here and we'll solve them and graph them and see what they look like. So in this first one, let's say we have m minus 2 is less than negative 6, or we have m plus 3 is greater than, let's say, 1. Okay, so we have two simple inequalities. This first inequality is considered a simple inequality because it's just one variable, one sign. We can just graph them. Same thing over here. So in order to solve each one of these, I'm going to do each one independently, the one on the left first and then the one on the right. So I can solve the one on the left by adding 2 to both sides. When I do that, these 2's cancel, and I have m is less than negative 4. And this or just kind of comes along for the ride. It's just really a comparison between these two guys. So it's this or this. Okay, so in this guy, we're going to subtract 3 from both sides. So those 3's cancel. We have m is greater than negative 2. So at this point, we've got our compound inequality that says m is less than negative 4 or m is greater than negative 2. And we're not sure which one we want, if we want the one on the left or the one on the right. So we go ahead and we graph both of them. And it kind of doesn't really matter how you go about graphing these things or the number line that you use, just so long as the negative 4 is on there and the negative 2 is on there. I'll have open circles at both of them because negative 4 and negative 2, and it's just less than and greater than. There's no equal sign, so it's just open circles. The negative 4, m is less than negative 4, so less than means we're going to come down this way. And the m is greater than negative 2, greater means we're going to come off to the right this way. And this is what our compound inequality looks like when we have the whole thing graphed. Because it's this side over here, or it's this side over here, and the solution set would be both of these put together. So we call this a union because it's the graph on the left and the graph on the right. You don't need to clarify that it's a union, but it's nice to put and you get the idea of what's going on here. So that's our first example. In our next example, we have a negative 3x minus 2 is greater than or equal to negative 8, or 2x plus 5 is greater than 13. So we're going to solve each one of these like we did in the previous example, completely independently. We do this one, then we do this one, and then we're going to graph both of them on the same number line. So on this one on the left, the first thing we do is we add 2 to both sides. That way we can get rid of these constants here. And we're left with negative 3x greater than or equal to negative 6, because negative 8 plus 2 is our negative 6. And then we can divide both sides by this negative 3 to get our x all by itself. And these negative 3's cancel. Recall, though, that when we multiply or divide an inequality by a negative, we need to flip the direction of that symbol. And then negative 6 divided by negative 3 will be a positive 2. Okay, so on the right one, we're going to subtract 5 from both sides to begin. And those constants cancel from over there. We have just 2x is greater than, we have 8. So we can divide both sides by 2, and we get x is greater than 4. And we have this or that goes in the middle. So it's x is less than or equal to 2, or x is greater than 4. So with my number line here, I'm going to graph both of them. Maybe put a 2 there in the middle, or 3 in the middle and 2 and a 4 on either side. And you could also go as far right or left or whatever you want to. Like last time, as long as we have the 2 and the 4 in clear picture and we can see what's going on. So we have a closed circle at 2, and it's going to be headed over to the left because it's less than 2. And these are our less than values. And then x is greater than 4, so it's an open circle at 4, and it's going to be over here off to the right because it's greater than that business. Okay, now, as we saw in the previous example, this is going to be a union because you have this guy over here going to the left, this guy over here going to the right, but you needed to keep both of them in mind, so we're going to call this a union. And that's the second example. In our next example, we have negative 3 is less than or equal to 5y minus 3, which is less than 7. So we talked in class about two different ways we can solve these because we have a trichotomy. We have 3 pieces, the guy on the left, the guy in the middle, and the guy on the right. And there's 2 ways to solve them. We can either break them up into 2 completely separate inequalities, Or we can just take it just the way that it is in this trichotomy form and then just solve it. So if you're going to take it all in this 1, the goal is to get this middle portion to just be y, or whatever variable you're working with. So in order to do that, in order to get it just to be y, first of all, I need to add 3 to here to get rid of the 3, and then we'll add 3 to all the parts of it, and since it's a trichotomy, there'll be 3 parts. Our negative 3 and plus 3 cancel, make a 0, and then we just have 5y then in the middle, and then 7 plus 3 is 10. Okay, now to finish getting the y all by itself, I'm going to divide everything by that 5. So the 5's cancel, and we have just y in the middle, which is what we want. 0 divided by 5 is 0, and then 10 divided by 5 is going to be 2. And we just bring down the rest of the symbols. This less than or equal to, and then this less than. So when we graph this, put my number line there, and I'll put 0 over here and 2 over here. And again, it doesn't matter what values you put down here, really, just as long as your 0 and your 2 are kind of in plain sight, we can work with them. So their 0 is going to be a closed circle, because we have this equal to right there. So closed circle at 0. Our 2 is going to be an open circle, because there's not an equal to. And in this trichotomy, it's going to be the stuff in between here, because if 0 is less than or equal to y, which is less than or equal to 2, the y business is going to be between 0 and 2. So I'm going to shade all the stuff between the 0 and the 2. Well, let's look at this another way a little bit. If we took this trichotomy, which we have for our answer, and we broke him up into 2 parts, we'd have 0 is less than or equal to y, and we would have y is less than 2. Let's go ahead and turn this guy around and say y is greater than or equal to 0 and get a better look at him. So we've got this guy and this guy. So this y is greater than or equal to 0. Really, he'd be a closed circle at 0, and you're going off to the right. This y is less than 2 would be an open circle at 2, and we're going over here off to the left. Notice here we have some overlap. So we've got overlap here, and we've got overlap here. And this is the part that we care about, where they overlap. So in our graph, you'll notice we shaded between the 2 points, and down here you'll notice this is y, because y is greater than or equal to 0, and y is less than 2, and we care about these parts where they overlap. So what kind of compound inequality is this? Well, we call this an intersection, because we only care about the parts where these 2 simple inequalities intersect. In this last example, we have another trichotomy with 3 pieces here. We have negative 9 less than or equal to, and this big quantity, 7n minus 3 all over 5, and then this business is less than 5. So again, when we have a trichotomy, we have 3 pieces, and the goal of this middle piece is to have just our variable, or in our case, just an n. So what can we do to make this just an n? Well, since it's a fraction, we kind of gonna want to get rid of that 5 right there. So I'm going to multiply everything by 5, times 5, times 5, times 5. Okay, when I multiply the left one by 5, I get negative 45. When I multiply this by 5, the 5 in the denominator and the 5 in the numerator here that I'm multiplying cancel out. And I have 7n minus 3. And again, that was the goal. And 5 times 5 is 25. Now this looks a lot simpler right now. So, and again, we'll add 3 to both sides in an effort to get our n all by itself. These 3's in the middle cancel. Negative 42 less than or equal to 7n, which is less than 28. And then to finish getting the n all by itself, divide everything by 7. So we have negative 6 less than or equal to n less than 4. And there's our trichotomy right there. So when we graph this rascal, we're going to have our number line here. And we have a negative 6, and we have a 4. And in the middle, if we wanted to be really good, we could put a negative 1 right there, because that's the midpoint of negative 6 and 4. So again, not necessary though. We have a closed circle at negative 6, because we have our equals to right there, which makes it closed. We have an open circle at 4, because it's just less than. And since it's a trichotomy, n is between these 2 values, negative 6 and 4, so I'm going to shade in between those 2 circles that I have. And we call this thing an intersection because, again, like we explained a while ago, an intersection because It's an intersection of these two things. This one goes all the way here, this one goes all the way here, and in the middle is where they intersect.